In this video we will talk about the differentiation of trigonometric functions, and we will see what are the ways to find the derivative of trigonometric identities. We are well familiar with the trigonometric identities that are sine of theta, cos of theta, tan theta, cot of theta, secant theta and cosecant theta. These are the 6 trigonometric identities, and now we will see how to find the derivative of such trigonometric identities. We can use first principle or definition to find the derivative of all of these, but the main focus will be the two basic identities, the two basic trigonometric identities, that is sine of theta and cos of theta. So let's start with the very first identity, that is sine of theta. So let's start by taking the derivative of sine of x. So there is a function y is equal to sine of x. We will use definition of derivative to find the derivative of this. So the very first step by using the definition of derivative is adding the change in it. So adding change on both sides, that is y plus delta y is equal to sine of x plus delta x. Now we have to find the difference of these two. We will get y plus delta y minus y is equal to sine of x plus delta x minus sine of x. We will get delta y is equal to sine of x plus delta x minus sine of x. Now we are well familiar with the formula that we know of this type, that sine A minus sine B is equal to 2 cos of A plus B over 2, and then the next term will be sine A minus B by 2. This is the very basic formula. So we will use this formula to evaluate this whole thing, taking A x plus delta x and B as x. So now applying the formula, delta y is equal to 2 cos of A is x plus delta x, so x plus delta x plus b, which means that plus x, divided by 2, and sine A minus b, A is x plus delta x and b is x divided by 2. So we will get 2 cos of 2x plus delta x divided by 2 and sine delta x by 2. That is equal to delta y. Now the next step is to divide the whole thing with the change. So delta y by delta x is equal to 2 cos 2x plus delta x by 2 and sine delta x by 2 divided by delta x. Now the next step is to apply the limit on the both sides. That is limit delta x approaches to 0, delta y by delta x is equal to limit delta x approaches to 0 to cos of 2x plus delta x by 2 and sine of delta x by 2 over delta x. As the limit approaches, delta x approaches to 0, but if delta x approaches to 0, then we can also say that delta x by 2 also approaches to 0. Why? Because delta x by 2 is a smaller term than of delta x, and if delta x approaches to 0, then this implies that the delta x by 2 also should also approaches to 0. Why we use delta x by 2 here? Because this expression, by applying limit, would vanish due to the sandwich theorem that we know. The general form of the sandwich theorem is that limit x approaches to 0, sine of x, this thing is equal to 1. This whole thing must be 1 if x approaches to 0, sine x by x. Here the situation is sine delta x by 2 over delta x. So we can use 2 here. We can divide or multiply this expression by 2, and by using delta x approaches to 0, we can also use delta x by 2 approaches to 0 in order to simplify this expression. Now this 2 will be written as delta x by 2 here, and the limit will change from delta x to delta x by 2 approaches to 0. So we can use delta x by 2 approaches to 0 here, and this 2 goes to the other side of the equation. Now this limit will apply to the both terms of cosx 2x plus delta x over 2 as well as this. So by using the laws of limit, we know that we can write here that limit delta x over 2 approaches to 0. This thing goes, we can also simplify this expression, because 2x by 2 plus delta x by 2, it will become x plus delta x by 2, and this expression, by after applying limit, will equal to 1. So there is no need of writing this expression anymore, and we are left out here with delta x by 2 approaches to 0 cos x plus delta x by 2. So by applying limit, as delta x by 2 approaches to 0, this factor will equal to 0, and we only left out with the cos x. Now we have seen that the derivative of sine of x with respect to x is cos of x, and we have proved it by using the definition of the derivative. So the derivative of sine x is cos of x. We can also find the derivative of y is equal to cos of x, that is rate of change of cos of x with respect to x, by also using the definition of the derivative. So the answer will come out sine of x, but with a negative sign. So this will also prove by the definition of the derivative. In the next video, we will see how to find the derivative of other trigonometric identities by using these two results, that is by using the result of rate of change of sine of x and rate of change of cos of x, and this will make the whole thing more easier. So stay tuned. Goodbye.